Okay, next up we have Bill McLaughlin. Bill is CTO at EEG and also now Chief Product Officer globally at AI Media. Since 2007, Bill has been with EEG in software development, engineering management, and product roles and has architected the company's leading software solutions, including iCap, Falcon, Lexi, and Alta. Come on up.
Hello. Today we'll be talking about translation of live media with AI models. And to go a little bit more into my background, at AI Media and EEG, we've been one of the leading vendors in the world for a decade plus in providing live closed captions with AI to broadcasters. To give you an idea of how successful that's been over time, we first introduced a product that was in live AI closed captions in 2016. And in 2016, we had a network of products that worked with human re-speakers and stenographers. And they were transcribing news, sports, live business conferences, all kinds of events. And it was 100% humans prior to that. At this point, we're running about 5 times as much volume as we were then. It's 70% AI and ASR with no human in the loop. So this has been tremendously successful at increasing the amount of caption media that's out there. And our own metrics, which we'll be going into this presentation, actually show that in addition to having more caption media and having that media be delivered at a lower cost to the content providers, it's actually also generally higher quality than was being provided by the human transcribers in real time. And so eventually, as you all know, in engineering, when anything's successful, eventually you need to reinvent yourself and move on to the next gig. So we've been looking increasingly at translation. And translation is really important because it's actually a way to expand the audience for content significantly more than same language captioning could. Same language captioning might, get you an extra single-digit percentage of audience that really is helped to understand by those captions. But when you translate content into another language, it opens up massively larger audiences. Even in a source language like English, that's probably the most widely understood language in the world, if you include second language speakers, you're at least doubling the number of people you can reach when you're translating into other languages. So this is commercially important for our customers, and propelled by the same basic improvements in large language models, translation is becoming more and more efficient and high quality when it's done by AI. So today, we'll learn more about that. So we're going to look at the translation world in AI through the same lens that we would use for live captioning. And that means looking at for a sample of the types of media that in general we have customers put through our systems, and using a strict latency constraint, how can we measure the quality of the translations to focus on understandability to the audience? We'll look at how that translation metric is comparing to captions and how it's going up over time and some of the reasons why. The primary measurement lens we'll use, which we'll go over in a little bit more detail here, is NER scoring. Some of you might be familiar with that already. It is embedded into the regulatory frameworks for captioning in a few countries, notably Canada and the UK. And it's a metric that seeks to look beyond just, is something word for word a complete accurate transcription, and looks at how impactful different errors are on the audience understandability. So it moves past some types of discussions about, say, a specific preferred formatting of a number, which may be less important to an audience, and more into when there's questions of misinformation or just total gibberish that would lose all the informational content of the program for someone who's relying on the captions to understand it. And thankfully, the inventor of the NER system, Dr. Pablo Romero Fresco, has worked on an NTR system that we've been partnering with him on evaluations for. And so it's a similar system for looking at translations. So in an example AI translation case, this is a business program. We have our, very attractive CEO, beautiful natural harbor, best in the world. And, there's information here, right? And audiences will want to hear this information in their own languages. And, producers of the information may want to share it with the audience. We can do that in a couple of ways. We can do that in a text-based way. As is shown here, we have 2 levels of subtitles on the screen. We can also move beyond the text and also incorporate text-to-speech and actually have a simultaneous interpretation track, right? So a voice speaking the translation in near real time, similar to what you would expect to see in, for example, a multilingual UN type of environment. This paper is going to mostly focus on evaluation in the text domain. There are some interesting side notes we'll give about the audio performance when you're actually doing a speaking track, but that tends to go into more subjective preferences that the evaluation framework's a little bit less prepared to understand. Translation quality is already very complicated. It's not the transcription quality is completely straightforward either, right? We have questions about should the transcription be more or less completely verbatim, or do we also want to include regulations for something like read speed, which might start to focus on issues like summarization, where you'd say, I want to get as much of the meaning as possible, but I also need to keep this at a good live reading speed. Translation is more complicated because in addition to the concerns around transcription, you have the fact that essentially communication through translation is an art. It depends on taking something from one language and moving it into another language and considering the amount of literalness that's appropriate versus how much idioms and even entire passages might need to be changed to something that has more cultural relevance for the audience in the destination language. There's more than one right way to translate something, right? The great books have been translated many, many times. There could be a lot of legitimate debate about which translation is better. It may depend on what you want out of the translation. So we try to go with a grading framework that's going to, let's say, not take a very opinionated view on these specific issues, but instead try to focus on a layer of simple understandability. Is this comprehensible? So looking a little bit more here at the theoretical NER and NTR formulas, it is basically a percentage. And so it's a number of markdowns minus, the number of words minus some number of markdowns over the number of words representing the length of the passage you're evaluating. The markdowns are not exactly just a wrong word, though, like in a word error rate score or even a BLEU score for translation, which is a simpler method which will simply look at whether a word is in the right position in the sentence or at least near the right position. This requires a human evaluator. And to do an NTR score, you have markdowns based on how the meaning is impacted. So in this slide, you can see a bit of the table that's used by a trained NTR scorer to determine how many markdowns should be given for a given phrase unit. And you can see that the basic idea is a full markdown for anything that is essentially incomprehensible or that contains misinformation or that omits valuable pieces of information that mean that communication hasn't occurred. And there would be a relatively minor error for things that, let's say, perhaps there's a grammatical error that, is not desirable, but also only has a small impact on the real understandability of the text in the language. That will only receive a minor markdown. There's also room for stylistic preferences. For example, use of the 12-hour versus the 24-hour clock in different cultures is shown here. That would, again, be a moderate markdown. It's something that could prevent someone from understanding you well. However, it's probably better than losing the entire thought. It's not totally incomprehensible in most cases. The markdowns are weighted in such a way to try to produce this table of overall subjective evaluation. So the NER and NTR work by Dr. Romero Fresco looks a lot at comparing this technical system to subjective evaluations, with the target that the NER or the NTR score aligns well with what an audience who isn't trained in a technical method for scoring of the translations would think about the performance. Essentially, is the performance perfect? Is the performance pretty good, but you may have noticed some errors? Or is the performance just distracting, not useful, not good at all? Of course, that can come relatively quickly. You can say something, in the old days, we would see something that was a 90% word error rate, and that sounds pretty good, except that isn't pretty good. If 1 out of 10 words randomly selected are omitted or wrong in a transcription, the overall effect is often close to unreadable. So, in this graph, you'll see in the blue, that's the performance of the most recent generation of our Lexi AI product delivered against real customer content. And in this generation of the product, which only goes back to about 2023, so this isn't really the beginning of the story as compared to ASR Captions, the NER has been assessed going from an average of 98.5 up to 99.2 over about 2 years. That is a pretty big difference in understandability, and that has subjectively been associated with a very significant spike in audience acceptance and in customer uptake of the system. So, as we've embarked on the translation journey, we've looked to say, how close are we to that curve? Are we going to see similar levels of improvement in translation? And what do we see as a starting point? So the translation evaluation program is in pretty early days. There's 3 months of data in the study. We've already seen a very significant spike upwards, and I would attribute that to working out basic kinks in the system, especially things involving phrase segmentation and how you decide in a real-time manner that a sentence or a phrase is complete enough that you can accurately translate it. This can be especially important in some language pairs where you have different ordering of subjects, verbs, and adjectives, and you really will wreck yourself if you go word for word, right? So there is a compromise between how much data you need to buffer as someone is speaking before attempting to render into a translation. Are we going to see that spike level of improvement until we get to 100 on translation? Almost certainly not. But if we revert to a more moderate level of improvement, similar to the graph for the ASR system, you'll see it's already about a year ahead on comparative performance. So we're projecting to see a 99 score on our average material probably before the end of next year. I think that that's going to represent a new level of technical readiness, as well as, what you see in the media with things like the AirPods that translate. It probably is prime time to start thinking about where we can use live translation in a media workflow. The system that's being tested here is a cascaded system. So another way to understand how the improvements are occurring is that improvements in the initial transcription layer, which are well proven to be happening, are causing improvements in the translation. If you don't have an accurate transcription, then you're starting from junk, you're going to mistranslate it. Often those errors compound and are even less understandable in the translation. So a very accurate transcription is key. And the very high quality of the AI transcriptions is part of what's making this whole thing possible. At that point, there's a text-based translation system and then a text-to-speech layer if you're doing an audio output that will actually, voice in a paced-out way just a little bit behind the original, the translated voice. There are other approaches that we're looking at which will use a model that isn't cascaded and doesn't have an explicit intermediate text representation, but is just trained directly on voice in and is designed to produce voice out. At this point, those models are generally smaller and more computationally intensive. In research, they show promising results, but commercially, we have not found that that's the time for that yet in a commercial broadcasting-oriented system. The gains of these systems are fairly low, and the complexity and the latency is generally much higher. Is it going to get there someday? Quite possibly. However, the text-based models also continue to get bigger and bigger and have more use cases and more users and more data going in and improvements in the way the LLMs are trained and constructed, so that it may turn out that there's a lot more improvement to ride on pipelines that have text as a key component before we're able to get a full advantage in a native audio pipeline. It's also true that in a case where you want captions and potentially translated subtitles, also that these are not just intermediate products, but these are part of what you'll ultimately be wanting to deliver, and so they're creating independent value. To go back to why we would be evaluating this and why it's important for anyone in the field to have a structured evaluation program, it's very important to developers. As some of these other presentations have referenced, you need to have a closed-loop system where you're taking feedback in to anything that's trying to use AI to get a desirable end result. If you're not doing evaluations, it's very difficult to tell if any changes that are being made by the developers are truly leading to a desirable outcome across the whole use case that you're using. You don't want to simply be overfitting to a single customer example or a single clip that the developers like to use. There needs to be robust testing at every stage of the process to make sure that your improvements are actually improvements. And the faster you can turn this around, the more established you can have an evaluation team, and the more tools and even some AI usage in the evaluation process, the better that you can get, the quicker. Beyond the development process, when you're doing operations, either at a vendor or at an end user who may be doing this in an internal operations team, evaluations are important to understand where small corrections like a specific hard-coded translation glossary or fine-tuning is going to be valuable to the application. So our products and most others like them would include a basic layer to provide glossaries for people who will be speaking at an event, for phrases that might be, industry specific and would have a very specific desired translation, for sports where the word for a field may differ depending on which sport you're talking about in a target language. So these are the kinds of things where at the user layer, it's important to evaluate and find room for improvement. So when we've looked at the fact that we basically have a high-quality translation system that's technologically available, that can give you a pretty good translation at a low latency, the next step, as we've discussed, is operational readiness. How do you put this into place? How do you evaluate it? How do you fine-tune it? How do you actually get it into your broadcast workflow, whether that's SDI 2110, any of these other standards, and make sure that you're putting out an audio stream that would actually work in a similar way to what someone might do if they were doing a much larger production with a remote commentary booth with humans. How do you get an AI system to fit in with things like broadcast scheduling? These are all critically important. and they need to be motivated by the commercial preparedness, because we know that it's going to be affordable for content producers to do AI translation on a much wider scale than the small amount of content where live human translation or alternate booths is used. But imagine you could do this nearly for free. In what cases does it really bring an audience benefit? Where can we find the additional audiences, the additional advertisers? How does this tie into marketing and branding? These are all discussions that we have with a lot of our customers. Essentially, it's great that you can do this, but where should you? So, in conclusion, this was a projection that our data team worked on based on an evaluation that the translation data over the next year and a half could evolve at least as quickly as the transcriptions have over the past year and a half. You see us getting to a 99 point and beyond by next year. Again, in the NTR system, this is designed to correspond to an experience that the audience is going to find highly useful. And while it's not going to be 100%, it's going to be more useful, we believe, than it is going to be, distracting. That's what it has to be for the audience. It has to be something that helps them understand the program and doesn't make them want to laugh or turn the program off. And we think we're delivering that value very soon. So, it becomes time to talk about implementing this. You can see a great demo in the Solutions Hub at the AI Media booth. So I'd encourage you to hop on over if you're curious. Thank you.
Thanks very much, Bill. We had a couple questions for you that came up. Are you guys considering as further advance in your solution lip sync localization, adapting mouth movements to video for the spoken language?
That is a really cool technology, and yes. So the questions about, lip sync movement, I think for live video with very low delay, that's probably going to be very challenging. I haven't really seen a technology yet that's going to do that in real time with very low delay, very accurately. It's probably coming. It can be done pretty effectively for not live video. So yes, I think that's something that is likely to come down the pipe. And, basically what we've learned from the caption experience on this is a lot of things that at first are, no, the product doesn't quite do that yet. Over the next couple of years, I would expect these things to be coming down the pipe, more understanding of the sound environment, auto mixing, lip sync, a lot of these environmental issues will be coming.
Great. Thank you very much. Is overlapping voices a solved problem when you're trying to do translation, or is it still something that's
is
overlapping voices? So someone talking over each other, particularly in
can be. Yeah. I mean, it's, in the captioning world, that's something that sometimes can be solved with transcribing separate mic feeds separately, but in a fully mixed program where you have overlap, sometimes compromises need to be made. What can be, a good lens is to kind of ask, well, could a human reasonably hear these two different streams and transcribe them accurately? Or at what point does a person just begin hearing chaos, muddle, dispute, So we try to get that as well as we can. And at some point when it becomes, over talk that's irreconcilable, sometimes, what a human captioner or anyone would have to do is essentially mark it as such, inaudible comments or a general commotion as opposed to specific voices.
Great. One last question before you go. Are there any specific languages you're currently working with, or is it based on client needs?
Based on client needs, I mean, we have worked in models. The data in this paper is from French and Spanish, and working primarily in North America. Those have been the two languages we see the most demand for. However, we have been working in models for about 15 other languages. So I expect that, like captioning, it's something where you will be able to find technologies out there for a very wide variety of languages. You will probably see the best quality and the best developed solutions on language pairs that are, the most commercially impactful and the most common. And so something that's often found together, whether that's, English and Spanish, English and French, French and German, English and Chinese. I mean, these are going to be very common pairs, and you'll probably see better quality. It also helps when the languages are more semantically related to each other. So, for example, multiple like Latin languages compared to working with East Asian languages, typically the languages are more different, which does generally have a negative impact on how strong the AI translations are.
Great. Thank you so much, Bill.
Thank you.